record. Okay, welcome to the session where Aarne is going to talk about GF for NLG for Wikidata.
Thank you, Inari, and also thanks for squeezing in this on a very short notice. I thought this would be useful, or interesting. At least it was interesting for me to see how much we can put into a rather simple tutorial where you just have learned a few days of GF and then go straightly into something that is, I hope, productive in some sense. So actually this tutorial will be very hands-on, and it will end with some exercises for those of you to try out who want. Okay. Why isn't it? Oh, yeah, it did. So we all know that NLG is there to replace translation, and there is this traditional workflow that is used in, for instance, companies when they produce material, and also in a sense it's used in the Wikipedia when English articles are translated to other languages. So you have some data or some knowledge more generally that someone writes into a master document, and then translators translate it into different languages. And NLG replaces this with a completely automated process where you have the data and then the languages are produced from the data directly without there being any master document. We will come back to the relations between these two pictures, but this is the very coarse baseline idea of what NLG is. The starting point here will be Wikidata, because that's the data on which abstract Wikipedia is intended to build on. And what is there in the Wikidata? So you can query it in the SparkQL language, which looks a bit like SQL, but then it's a bit different. And then you have these strange identifiers. But luckily, if you use the Wikidata query interface, you can get help for choosing the identifiers. So this is basically the table, creates a table that I want to use in most of the following. It looks as follows. So you have countries with their capital, area, population, continent, and currency. There are about 190 or so in this entire data that was obtained by that query, with some duplicates and some other things removed. So the first step here, that I'm doing is actually to get from an RDF triple data to a tabular data, because it has some more structure. But this is already something that you can export from Wikidata by pressing an export button. So you get a tab separated or JSON or whatever format for a table. So our plan here is to make a bottom-up development of an NLG system, and we start with something that is basically templates for atomic country facts. But the templates are implemented in GF. So this is just to show that there is really no contradiction between GF and templates, because templates are just a special case of what GF is. And then we proceed to grammars, we proceed to more text planning and content planning. The system architecture will be always the same. So we have some data, and we have some GF grammar, abstract grammar, and then the concrete syntaxes. Between the data and the abstract, there is a Python module. So this could, of course, be some other host language, but I'm using Python because I thought it's the, maybe it's a candidate for a widely known language, and also the Python GF API is very nice. I have actually been learning more of this when preparing for this talk. So template-based generation of atomic facts. And the result of the generation looks like this. So they always say the attribute of country is value. And the GF grammar for this, so there is a category of facts, and you basically build it with the abstract function attribute fact from an attribute object and value. And there is a short list of attributes, and you might recognize these as the names of the columns in the table that we started with. So there was a column for capital, area, population, continent, and currency. There was also a column for the country name, but we take that to be the key of these tuples. So in a very simple fashion. And you can actually always organize your tables in that way, that there is a key, at least in this simple setup. Then for the objects, so that's the names of the countries, we just use strings directly from the table, and for the values, the same thing. So we don't even care about whether it's a numeric or a character or letter-based, name-based value. So if we now want to say that the population of Argentina is 4 something, then this is what the abstract syntax tree is according to that grammar. And this is the concrete syntax. So you can see this, recognize the GF syntax here. So it's facts n of facts, and then you have the linearization types are just strings, and then this is really the template where you insert the attribute, the object, and the value between the words the, of, and is, and then you give English words for the attributes, and then the strings are just, well, internally string objects in GFR records, so you have to select the .s from them. And this is the Python program that generates or that's the function that generates facts for each country C. So you get the string object from the name of the country, and also from the string value from the whatever there is in the value column, and then you build this attribute fact expression with these 3 arguments. And the attribute value pairs you get from this this tuple, which is the row representing the country, and then I'm here using a named tuple of Python so that we easily get can easily see what is happening here. This could of course be done even easier by using indexes, but I think this is much clearer to do it in this way, especially when we go further and want to do more NLG. So the code is always, you can find it on GitHub in the linked places. So this is the Python program that generates a list of abstract syntax tree using the GF Python API, building an expression in this way. And then the main program just reads the PGF file, reads the countries, then builds the list of all of the languages, and then for all of the languages, it loops over all the languages, and then it loops over all the countries and generates all of the facts about these countries. So this was completely language neutral, so you can add any number of languages here. So we had German, so there is actually, the differences are in the names of the attributes, and they are in the this template, of course. You can also see that in English we had the definite article as a part of the template, but you can't really do this in German anyway because the article changes in or varies in gender. And then you get this text for German. For Finnish, it's obviously a bit different, and there is a little hack here that in Finnish you actually should, in any case, inflect the name of the country in the genitive, and that can be quite demanding, and we will solve it in the next phase. But we use a trick that is quite common, for instance, in the Facebook when they are generating reports. So they say that your friend X is in country Y instead of saying country in the case that it requires. So when you then build a system, so you build a PGF for all of the facts grammars that you have, and then you run this facts Python, and then you get all of the 200 times 5 times 3 texts. Okay, so that was the template-based generation. And notice that you can easily do this for any table by just modifying what attributes there are. So you don't, well, maybe you need to modify the template a little bit, especially in Finnish. But otherwise, this is ready to be used. You don't need to change in the Python code, you also need to change, in this case, the attribute names. So here we are introducing grammar in the next stage, and we also divide the code into 3 modules because this will be more scalable. So we have facts, kind of a generic module for expressing different kinds of facts. Then we have country names, a huge module, which has all the names not only of countries, but their capitals and continents and currencies as well. And then they are put together into module countries. And then the idea here is that you could vary the domain by, for instance, having Nobel Prize laureate names, and then you have a top module that matches that. Or you could combine, for instance, university names and country names, and then you could have a system for universities telling which countries they are in and so on. But this is the minimal module structure here. So the abstract syntax is a bit smaller than before, but it introduces a new category name, which we use instead of the string for objects and values. So both values and objects can be now names, and then we use integers for values as well. And we use the resource grammar. So we need symbolic to use the integer. This might be doable in a better way as well, but it's the simplest way to do it. And then we have the attribute fact. Now this requires some knowledge of how you read the resource grammar API. But it basically builds what we had before, the attribute of object is value. So we got previously the population of United States of America is this, because this was what we got from the also of the name as the name from the Wikidata. But then when we have a grammar for names, so we can actually have a more put the definite article here, which usually is used there. And then we could also take a step to a more attribute-specific rendering. For instance, the United States has 3.1 and so on inhabitants. So first we port this concrete syntax to German, and it looks actually exactly the same as for English, so we will come back to that. But it's basically the only things we change are the name. So ing is changed to ger here. And then you get this, for instance, you get here an inflection of United States. You might also want to use the genitive case, so that would be another possibility, maybe better for German. My German is not good enough to judge which one is better. But you see that here, the United States, Die Vereinigten Staaten, is actually, it's inflected in two different ways here. Den Vereinigten Staaten in the dative and Die Vereinigten Staaten in the nominative. Also notice that it's plural in German. And then in Finnish, so here we actually, we had this problem with man, and now we want to get rid of that. So we use a proper genitive construction for country names, which we get from Extend Finn, because the genitive constructions are not available for all languages in the same generality as in Finnish, and also in German, actually. So now you see a very big difference. So this was what we had in the template-based generation, and this is what we have in the grammar-based generation. And this is the third one, is when we add this attribute-specific rendering of the fact, saying there are 3.1 and so on inhabitants in the United States. So where do we get these country names from? We can get them with another Wikidata query using the label relation. And from this, we can actually extract names. So there is also a little script for doing this. It works almost automatically. You have to do a bit of post-processing, but that's what it gives you. So it gives you generates function names and then their English linearizations. So from this, you can grep the country names in the abstract syntax. And here, one should be careful to use some specific categories. So C name for countries and for what we have here, because it will turn out that they may need to be a bit different from names in general, because we have to talk about the locations, for instance. And then you get the concrete syntax out of the box, but then you may want to edit this a little bit, for instance, to change this big expression for United States to something simpler. But there is more of this editing in the other languages. So here I got these country names in a table, and then there are different columns give labels in different languages. So I want to get this in German, so then I change the target field in the script, and I get the German concrete syntax. And there I have to take it seriously that the country names are noun phrases, but they might also have some more structure than just being a string. So if you have Guinea-Bissau, so this is just a string, it works okay. But if you have the United States, then you actually have to give it this structure of being the plural determiner of Vereinigt and Staat. For Finnish, you have to do even more. So of course, I'm not going to explain you what all the complexities of Finnish are, but there is something that you will also need in other languages sooner or later, which is that country names may have different prepositions that they need for location. So in Finnish, it's basically if you use the in preposition or the in cases or the on cases. And the default is to use on cases, sorry, in cases, but for some, for instance, island states or states consisting of many islands, you use the on case. And also for whatever reason, for Russia, you use the on case, even though it's as far from being an island as anything. So, and for the United States, there is something even more peculiar, but that can be the case in many languages. So it's internally a plural, United States, but externally it's a singular, so it agrees like a singular noun phrase. So you have to change some of these names, so the wiki data doesn't give you all of this information, so you have to put it there and use this special category, which you here see that it's a bit different in the different languages. All right, and then when you put it all together, so you have to three things here. So how you use the special categories, what properties there are, or the attributes, and then what any number of these specialized expressions for the attributes. So for English, there is kind of no surprises here, I would say. I will not go and explain this more. For Finnish, you have some more things. So here you have to change, inspect this parameter and change the case that is used for the location in that country. And then this is the Python code. So now the Python code is divided into different modules in the same way as the grammar, not for the names, but for the basic facts and for the country facts. So for the basic facts you have, and then there I found that some kind of an object-oriented design is good. So because there are so many things that belong into an building a system for a certain domain. So we have basically three things that define the class. So it's the names of the fields. So for instance here, country, capital, and so on. Then you have the grammar, and that's actually a PGF grammar, although you can't see it because there is no type annotation here. And then there is the language in which entities are parsed to trees. So this is a bit surprising maybe that we will use the parsing in the generation, but you will soon see why. And then there is, of course, a method of getting data. So you get a named tuple by using these field names. And it's a tab separated file, so nothing surprising here. And then you have another method for running the fact system with some data file and some fact generator. And the fact generator itself is a function that turns data into a list of trees. Okay. And then when you run it, so you build a fact system from some field names and some PGF file, and you give countries Eng as the first language, and then you run this. Okay. So what is this simple fact? So now it is done in such a way that it's actually domain independent. So we are just assuming that the first column, the 0, 1, contains the key. So here the country name, and then we generate an attribute fact for each cell in this table. And here we use this string to exp. So we assume that these attribute names here are now in the same, they are in the language that you can parse in. So when you see the, for instance, population, so then it's an attribute that can be parsed as an attribute. Here I'm of course using English, but actually if you want to have it so one can have a separate concrete syntax for these meta things to make it a bit cleaner. But this is the simplest way to do it, and actually then this becomes completely generic, so you can use it for any table and any attribute system, and the same for values. That you parse them. So yeah, so this is a string to X, so it tries to use the parser, and if it fails, so it gives you a warning. And here is what you get when you run it. So now it gives kind of more nicer and more grammatical and in any case language with native names of things. There is a separate module for country facts, which builds on the data facts and in particular the fact system class that is there. And there it has these two attribute specific functions just as a proof of the concept. So you have, you don't say the population of, but you say has inhabitants, and you don't say the continent of, but you say is in. And in German, you don't say is, but you say lies in North America. So this is how we define this country facts by using an embedded grammar. So this was one of the new things that I learned recently from Python bindings. So you can actually import a module from a grammar abstract syntax, and then you can, in a nice way, instead of using this expression class constructor, so you can build trees in Python by using functions from this imported module that has exactly the same structure as the abstract syntax. And of course, the one advantage of this is that you have to follow the arities of the functions. So you are not generating some, you can't easily generate junk trees. Of course, there is no typing of the trees, but still this helps quite a lot. So you get the correct names of the functions and correct numbers of arguments. And this is, of course, much more compact to write than by using this.
Are you sure that the binding actually checks the number of arguments? I don't remember that.
I have tried it. I have made this mistake with a number of arguments, and then I got it wrong. Yeah.
So I learned something new. So although I wrote it many years ago.
Good. So yeah, that's one way. So we call it the embedded grammar way. But now actually, then I noticed that this string to X can be used in another way. So you can actually use it so that you parse the input to the generation from your input language. And this is in this case just the English, but it could be some of other more schematic language that you are not interested in, maybe less ambiguous. And then the way you build the NLG input is actually, it looks exactly like templates, but in this case, so you for each country, you actually use this format method of Python by inserting the name of the country and the capital here, and then parsing this, and then you get an abstract syntax tree, and then you can generate the other languages from that. So templates are back in this more indirect way of using them. What you have now is, of course, a much more complex system, but it's still very systematic. So you have the countries, facts, and country names, and you have their concrete syntaxes, and then you use the three resource grammar APIs, symbolic, syntax, and paradigms. Okay, so now we have built kind of grammatical text for different languages and in an so that each individual fact gets generated separately. Now we want to make the text more fluent, and here is how it would look. So you have the United States is a North American country with 331 blah blah inhabitants. Its area is 982 blah blah. The capital of the United States is Washington DC, and its currency is United States dollar. So that's the text that we generate by putting together some facts. So we have actually used two NLG techniques, aggregation and referring expression generation. So aggregation is done either with a conjunction like here, and this is just simple aggregation of sentences so far, and here with a prepositional phrase that adds a modifier, a country with 331 blah blah inhabitants. And then the referring expression in this simple proof of concept is just the pronoun. But notice that the pronoun has to be generated. It has to agree with the gender of the country. So here, actually, it's a plural pronoun. Yeah, that's it. So aggregation and referring expressions. And what we need in the to add to the facts module now, and this is in the our final directory facts3. We want to have a structure for the complete document, which consists of sentences which are built from facts. And by using, yeah. So that's one thing for the aggregation, the conjunction. So actually I didn't see show the other aggregation yet, but you will see it at least in the code. Then there are two ways of building an object from a name. So it's either the name itself or the pronoun from the name. This is how you build the embedded tree of the country texts. And I think this is, of course, very precise, but it looks a bit daunting to write it. So actually, you can also parse this text from a template again. So yeah, it looks a bit nicer to me. Of course, you can combine those two. So it's maybe a good thing to do, a hybrid of parsing and embedded grammar functions. So now, before we go to the last phase, the stage 4, we take a look at how the concrete syntax is defined. And this is now without going into the details. So this is the abstract syntax that I'm using for both stages 3 and 4, which have aggregation and also some other tricks that we haven't seen yet. And of course, this is just a small part of a high-level abstract syntax that you would use for data generation. It has been annotated with comments that say how the English sentences or phrases will look like. So the idea is to make it easier to write templates that correspond to the different functions. But anyway, so this is the abstract syntax. This is the beginning, maybe half of the concrete syntax in English. And this is the concrete syntax in German. And maybe some of you have seen this trick before. So it looks like I can build it by copying and pasting. And that's what I don't want to do. So instead we use this functor here. So the functor is a concrete syntax that imports or opens interfaces instead of concrete resources. And the resource grammar modules syntax, symbolic, and grammar are actually interfaces. And then you have exactly the same code here in the body as before, but now it is done in a generic way. So you can then instantiate it in the different languages by just saying how each of the interfaces is instantiated. So this is how you port it to English, and this is how you port it to German. And this is what actually makes it quite painless to add languages. So, and not only that, but it also makes it painless to add new functions to the API, because you only need to write the linearization once, and not for all the 300 languages that you will have in your complete system separately. So this is the module structure when you are using a functor. So just for the facts part, so it opens facts and uses facts functor, which uses symbolic and syntax, and which are then implementing implemented by syntax and then symbolic eng. And the paradigms eng is not in the parts that are needed from the paradigms eng are actually not in the functor, but they are used directly. So here is what we might expect for Finnish, but unfortunately, so when you are adding a new language, so it may happen that something doesn't work quite as well. So then we use this restricted inheritance with an exclude list, which means that we take everything from facts functor except attribute fact, which we already saw at stage 2. And then we define it in the same way as we did there, using this extended Finnish. So the rest of this module is just like before in the usual concrete syntax. And also one would say that the truth is a bit more complex. So there are a couple of things that we don't have this in this functor anyway, at least in the version that we have. But there are some functor parameters, so we want to insert adjectives for large and small and total and only, and then there is also some functions that use some paradigms, like the word for million and billion. There is a cleaner way to do this by separate interface modules, so maybe in the future, but this is the quick and dirty way of using functors, and I show it explicitly here because it's not documented in the GF book, which only acknowledges the separate interface modules. It maybe is possible because of a certain gap in the type checker of the modules in the GF compiler, but since it has been used so much, so we can't take it away, and it's actually quite handy. So you get a slightly smaller number of modules in your system in this way. Okay, so we come to the final stage of today, selecting content. And by now we have been selecting the content basically with the original SparkQL query, and then we have generated natural language for all of the content. First for all of the cells in the table separately, and then a bit more text planning fashion for each row by using aggregations and referring expressions. But now we want to have some derived facts, like we use the same table and then we want to derive facts about the world and facts about each of the continents. So this is an example text that was generated with the world facts module that I'm going to show. So you have the count of the numbers for the countries, first of all. Then you have the total population, which is the sum of the populations. Then you look for the largest population and area. and then you look for some interesting facts like that which countries have over 1 billion inhabitants, and that's India and China. And here, of course, you could, if you are interested in this construction, X is the only Y that Z, then there are very many facts like that that you could extract from the data. For instance, Africa is the only continent that has 54 countries, but that's not very interesting. So here the content planning actually becomes a bit more critical. So what exactly you show, you are not deriving all the possible facts, but a selection of them. How you do this? So the aggregation is now, that is something that we call data aggregation. So it's aggregation in the same sense as in databases. So you have things like length of a list, the maximum and the minimum, that would be, of course, and then the sum. You could also have the average. And then you, yes, then you analyze the data, looking for the maximum and the sum and so on. There's also ellipsis that is introduced here. So if you look at this carefully, so then it says Nigeria has the largest population, and Algeria has the largest area. So it doesn't say Africa, but the ellipsis is possible as a referring expression because you are in the context of talking about Africa. And here you are in the context of talking about the world. So then this looks like the contradictory sentence to this one, but of course it isn't, because it's the ellipsis has a different value. So for this purpose, you need to have some support in the GF grammar. So I already showed this in this big file, but just zooming in to these aggregation constructors. There's also this unique in kind. So O is the only K with something or that something, which is actually a part of the K of the kind. So you're modifying the common noun phrase there. And now if you want to say X is the only K that P, so it's actually a derived fact and it's correct by construction because you generate it from the data. So you generate this list from the construction. And here you are interested in the countries that have more than 1 billion inhabitants. And if there is one of them, so then you use is. So actually this is a bit ugly that you have to do it in the, but it's just because I'm using the string template here. And if it is more than one, then it's another string that you are using. And then if this list has any elements, so then you add this sentence which says that these are the only countries with over 1 billion inhabitants. But if there are no such countries, then you just leave that sentence out. So you see that you don't have it in the Africa text, but you will have it in the Asia text. So who selects this content? And in the earlier stages from 1 to 3, it was the Spartual query that selected the facts, and then all facts were verbalized. But now we have, on stage 4, we have introduced this world facts function continent text, which selects the data for each continent and for the world. So it has been handwritten. But it's still kind of an algorithm. So when you run it, so you can run it on any data and any continent, and it's not sure that you can always select the most interesting data in this way. And I think when you want to do this more like a natural language kind of article generation, then the authors of the documents must be in control on what data is selected. And technically, this would mean that they produce the master documents in abstract syntax. So this is the bottleneck now, where you have someone who creates the abstract master document, and then the NLG takes over and generates these different languages. And so this is similar to the traditional picture where the master document was written in English and then some other people were translating it. But here, of course, the other languages you get for free in this setup, and it can motivate spending a bit more time and care in producing the abstract master document, because you know that you will get the translations. But of course, we want to do this as easy as possible so that actually the author could be anyone with skills of an Wikipedia author, more or less, without programming skills. So the basic way of doing this is, of course, by writing abstract syntax trees, but then you could then also write programs that produce abstract syntax trees, and that's what we did in Python, and maybe that's something to export as wiki functions. But then we already saw that it's actually possible by using the GF parser is to write a natural language. We did it for both concrete strings and for templates. So that's what the fact system.language1 is supposed to provide. And it is in any case a controlled natural language. So it's a language which is defined and thereby controlled by your GF grammar. So it's not open-ended natural language. So then the summary, and maybe those of you who have worked with NLG and with this very influential textbook by Reiter and Dale, so you wonder where we have these different stages that they are talking about. So you have this pipeline where NLG starts with content determination, goes on to discourse planning, sentence aggregation, lexicalization, referring expression generation, and finally linguistic realization. How this looks in our setup is that, well, we of course had to do all of this. So, but in stage 1, so it was very, very simple until stage 3. So we take all facts in the data. And then on stage 4, we added semantic aggregation. Discourse planning was done fact by fact here, and then we added syntactic aggregation. So sentence aggregation and discourse planning were actually, we kind of fused them together. So there's no clear difference here, what I have seen here. Maybe that we did not only sentence aggregation, but also some other aggregation. Lexicalization, so first we used just data strings, and then we went over to the data labels from the Wikidata. Referring expression generation, so first we were only using constraints, and then we used constant, also pronouns, and then we also added ellipses. Linguistic realization, first just template, then RGL, and then RGL functor, which to me looks like the most productive way of doing it. So this is what I have been showing in this simple tutorial, and then there are many more things that one could do. So interactive authoring for content determination. Then for discourse planning, I think an interesting thing would be to collect text patterns from actual Wikipedia articles and see what things are actually interesting what are the kind of idiomatic ways of expressing different things. Sentence aggregation, so I think aggregation in all categories is the minimal thing to be added there. Lexicalization, so data labels are a good source, but I think even more could be gained from WordNet, and maybe the WordNet that Krasimir presented earlier today could be kind of exported back to some of the data labels in the Wikidata. Concept alignment, which Arianna will talk about, is another way of lexicalization for multi-word concepts in particular. Then referring expressions, so we didn't have definite descriptions yet, and that would be obviously something to add. Linguist realization, so there is a more modern trend in NLG, which actually comes from, so this thing called BERT, for instance, and this GPF, what is it, 3, which is another language model-based generator, which has a statistical model for how to continue a given string of words. And this can be a kind of a way to add to make the NLG more fluent, but we still want to keep it under control so that you know that it is expressing what we want and not something random like it does in this purely language model-based approaches. So I promised to end with some exercises, and here are some possible things which you could try out, and you find the code in this repository, which is very experimental, but at least the code that I have shown here is there. There's also a full text of tutorial which actually tries also to introduce all the GF that you need. So it's a kind of more aimed to be used in more generally than this tutorial on the second week of the summer school. So the relevant code is actually the code that is in the subdirectory for that tutorial. And so you could take that and then try each of these things. So you could just need some GF if you add a language in the for this basic country descriptions. So a very simple template for your own language. But if you want to have the names of the countries and capitals correct, then you would need to harvest from Wikidata in the way that I showed on one of the slides. Atomic fact expressions, so there was nothing on stage 1, but at stage 2, so then you would need to define something in GF and then some Python code that uses it. The same thing with syntactic aggregations. With semantic aggregations, so you can, since there is already a kind of API with many GF functions, so it might be enough to write something in Python, but optionally you can add something in GF. Data, domains of data. So once you get the Wikidata, so you actually just have to change the GF in the minimum. But if you want to have these atomic fact expressions, then you would need some Python code that uses the new these atomic fact expressions in the NLG. What about if there is no resource grammar yet? And this is, since we only have about 40 resource grammars and we are aiming at 300 languages. So the good news is that you don't need the full resource grammar to do what was shown here. So I produced a list of those resource grammar functions that were actually used when you resolve the overloading. And it was not that much, I would say. So there were 23 at stage 2, if I remember correctly, and 57 at stages 3 and 4. So that gives some idea of what things are good to start with if you want to build a resource grammar for the use of Wikidata NLG. Thanks for your attention.
Thanks, Aarne. Questions? Just a quick, so you in the list of 23 things, like you didn't have anything above PredVP, but you would actually need like UCL and some tense and territory also, or is that like actually a full list?
I thought it was a full list.
Or I don't know, maybe I just like didn't see it properly, like maybe I just.
Yeah, so, or then my extraction method was not, yeah, there was sentences saying .predvp, right? Yeah.
But I didn't see UCL or @s or like.
Yeah, because the clause was the top category that I was using.
Oh, okay, right. Okay.
But well, yeah, you are right.
I see. Yeah. Okay. Yeah. I understand. Yeah, Michael, go ahead.
So I assume the grammar is bidirectional, so you can go from text to data as well.
Yeah, so this is so actually when you are doing up to stage 3, then it is actually an unfaithful representation of all of the data. So you can retrieve the data from the text by using the parser. Of course, there can be some ambiguities, like ambiguous place names in some languages and things like that. But
so we're back to AceWiki, where you can type text in a natural language and get some kind of machine understandable data from that.
Yeah, that's maybe one new way of using it if you want to kind of populate Wikidata in that way.
Of course, that's just
yeah, but this is a good idea. Actually, I didn't think about it, but it's quite, because someone has to create the Wikidata.
Yeah.
And
who creates Wikidata anyway? Who encodes all those triples?
Do we have any Wikimedia people here in the who can answer this?
I don't know. They just kind of magically exist there. But
no, I think everyone should contribute to creating Wikidata.
I think the data mostly comes from importing existing databases.
Yeah.
Like governmental data or whatever I can find.
Yes. Yeah, that's the obvious source. So why create everything from scratch? This can be.
Okay, yeah, that was just a. I know that's not the point.
No, that's
this is about NLG, not about parsing.
Yeah, no, but I think so. I don't think NLG should be completely ignorant of parsing, so to say. Yeah. Parsing is useful.
Well, there was a small bit of debate about it in after the talk by Denny, where he was sort of expressing his vision for how people would be authoring the meaning independent representations. He was showing us his kind of glorified syntax tree editor. And he was hoping that people would be able to edit that and actually create content in that formalism. But as a backup plan, you might want to have some sort of a parsing mechanism there where the parser parses your text into its best approximation of an abstract syntax tree, and then you can edit that, right?
Yeah,
So
yeah.
that's probably a more realistic scenario than expecting ordinary people out there to be able to edit syntax trees.
You know, I found this myself when I was writing these Python functions, that it became increasingly difficult to keep track of these abstract syntax tree combinations. So then I thought, why not parse and use create?
Yeah. That's also one of the approaches we're doing with L4. So it's kind of, yeah, it's kind of natural. But okay, let's, we can take Krasimir's question.
Yes, so in your experiment, you still use quite a lot of Python, and then you also wrote an application grammar and a lot of stuff. And this requires at least fair amount of knowledge about computer science. Well, the Wikipedia authors are supposed to be not programmers, normal people. One way to simplify things is that you can parse with the resource grammar instead of with application grammar. This will probably improve something. And then maybe you can replace most of the Python code with wiki functions. Do you see something else that would be needed to make everything easier? We want very low level of computer science knowledge for this to be successful. I know this was not the goal in your experiment, but maybe you have some intuition.
Yeah, no, I think it's, you have the different roles here. So there are people who write the articles, there are people who write the wiki functions, and I think there are also people who write the grammars. And then yeah, so this tutorial was meant for those who write grammars, but then it showed that you can actually, for instance, when you are using the functor, so then you can get started with a new language by writing much less of a grammar because of that, even as a grammarian. But if you are writing an, let's say there is a new country and you just want to write an article about that, so then there is not very much more than you need to do.
Yes, but still the number of people who can write GF grammars, even if I count everyone who is in the GF dev group, these are about 200 people in the world. And if all of them volunteer to write grammars for Wikipedia, 200 people is still not, it's not too much.
Yeah, no, I think we need more people to write. If we want to have 300 languages, then we definitely need more people who write grammars. But
yes.
But as I said, there are different roles. I don't think everyone who would author Wikipedia articles has to write grammars, but it's...
No, of course, but this is still this will be very highly demanded skill. Yes. Because for every genre, for example, for countries, you need one set of functions. For, I don't know, to describe the electron, you need some other set of functions. And for every domain, you have something different.
Well, you also have a lot that you can share, so it's not that everything is different.
Sure, but still, new things will pop up all the time.
Yeah, no, I think it's like Wikipedia itself, so it's open-ended.
Yes.
Can I say something about that? I think that facts about countries that's not a very convincing use case, because there's only about, I don't know how many, about 100 countries in the world, and they don't really change very often. But in other domains, you could do something more amazing, like, let's say, if you write an application grammar for writing facts about, let's say, the villages of in your country or whatever, you know. I mean, there are many more of them, and most of them, nothing has ever been written about them. But there are statistics which tell you facts about them, you know, how many inhabitants, where they are, and things like that. So if you could write an application grammar and then generate half-page description for each tiny little village that exists in your country and put them up on the internet, then suddenly there is content about this village up there somewhere that didn't exist previously. So there you can achieve some sort a bit of impact, you know, with so yes, you need to be an IT person, you need to be able to write application grammars, but in this case, it's probably worth it because you can suddenly write, you know, 50,000 half-page summaries about things, and manually you couldn't dream about writing that. So
this has actually been done in, for instance, in Swedish and Cebuano. It's the same person who has created millions of articles about different small entities. And that's called Text Robot. And the thing there is that there is no data selection really individually based, but it's for each village in the database you generate this exactly the same kind of an article. But it's, of course, it's very helpful. So and if we can do it for many languages at the same time, so then that would be a next step. But to me, I think this text robot idea, which is a good starting point to show that it's possible to do something useful and impressive with rather simple means with NLG. Then I would be a bit object a little bit to this saying that there is nothing that happens with countries. So you have things like for these derived facts. So let's say that I didn't have very many of them, but you could have things like X is the only Y that Z, and such things can change quite easily. So I was thinking about, for instance, Iceland is the only Nordic country with less than 1 million inhabitants, and then next year it can happen that Greenland becomes independent, and then that sentence has to be updated in all of the Wikipedias, and the way to do it is NLG. So things can happen in countries, and of course their populations change all the time, and maybe currencies change now and then, and so.
Okay, Normans.
Well, thanks for this very nice tutorial and discussion. Apart from grammar engineering, which of course is not a trivial thing, I think this lexicon part is a big challenge. And in case of countries, well, this is a very small restricted set where you can go through all those 200 names and correct if anything is needed. And it always works for English almost out of the box from the data labels, but then for other languages, in case of inflective languages, you have to tweak it. And yeah, I'm just wondering how to solve this issue on a large scale for categories where there are thousands of items, where you cannot so easily go through and fine-tune everything. And the WordNet is one thing which could help in this GF WordNet linking, but then are other sets of named entities which are not covered by WordNet, and well, this is just a wondering, but if it would be possible to bring this lexical knowledge back to Wikidata, apart from data labels, theoretically, well then, in a long term, this could solve probably this.
Yeah, no, I think it was part of Dennis' talk, actually, if you saw that, is that Wiktionary has much of this information, but it's not really structured. It's HTML tables. And they would like to get it back to Wikidata, and thereby there is an interest actually in having all kinds of grammatical information of the terms in the Wikidata format. And that's actually something that was, I think Christian mentioned it once, that's kind of a low-hanging fruit for us would be to populate Wikidata with such information. So I think for many of these things, so it's good if you can automate creating something, but I wouldn't be too afraid of going through things manually, because if it is something that is reusable and of good quality, so then someone has to do it anyway. So, we also saw in Krasimir's talk that there is this WordNet and combination with other data sources. So you have some data which is not of such high quality, but when you get a baseline generated automatically, so then it's much more productive than to go through that. So for instance, I didn't want to write all of the country names in Finnish by hand. That would have been taken much more time than. But if they are not in Wikidata or in any other known source, so then I think one has to go to the basics at that point. Whereas if you take all the villages of India, let's say, so I don't think there is very much I would need to do to get the Finnish names for them, because they would basically be the same names, and I would just have to pick the right inflection of the names, which is simpler for foreign names than for native names.
I think Danny's answer to that was to just rely on the community. You automate as much as you can, and then you rely on the thousands of people who read the text, and maybe some of them will correct.
Yeah. But then also, I think we who are, so to say, working on a higher level, so we should show example, and we should not be afraid of doing some donkey work to get things.
Well, definitely not. I did a lot of donkey work as well.
Yeah, that's what I already said.
Okay, donkey work is my new favorite phrase.
Do you know where it comes from?
Well, I suppose donkeys have to work really hard. So,
but in this connection, I got it from Alan Turing biography. So his first computers in Manchester, and he got his friends who were and colleagues who were very enthusiastic about this, but they didn't want to see the trouble of writing all the subroutines that they needed. So then Turing said he has to do this donkey work to get it all going. Yeah. So I hope this is still your favorite.
Yeah, I'll probably use it. I tend to have to outsource a lot of donkey work to other people in my day job. So now I know what to call it.
Just don't call them donkeys, otherwise they might not interpret it in the right way.
No, we call them students.
That's a silly, isn't it?
No, I think I and many others have this experience that donkey work can be nice. So it's kind of meditation. You do it at your spare time, and then you know that every character you write takes you closer to the goal. So
I agree with that.
It's much more rewarding than thinking about some very, very, very sophisticated problems where you might make lots of trial and error.
I'd say that even writing application grammars in GF could qualify as donkey work, because it's a lot of kind of detailed work on a relatively small scale, and then you end up with a grammar which generates maybe a couple hundred sentences. So I know I've spent days and half days writing grammars where I could have just written the sentences by hand faster, you know. So maybe there's a continuum of how much a piece of work could be described as donkey work or not. it's a continuum.
Well, on the other hand, the first grammar that I showed here, so it's 10 lines and it generates thousands of sentences. So it's
Yeah, like we need to get like a formula for like, is it the matter of ratio of input to output, but also another factor is like how sophisticated the work is. So like if it's just string templates, it's not as like rewarding as if you're using the RGL function. Okay, any more questions about the topic? Like, light here.
I see it's late in Singapore.
Yeah. Okay, so if no more questions, we can wrap up this talk, and tomorrow we have a lot of the theme of tomorrow is like GF and linguistic diversity. So we start by I'm gonna just talk 2 hours about well, you'll see, and and then we have lots of different languages in GF in the evening. So.
Is it worth getting up at 4 o'clock in the morning?
I mean,
okay,
up to you. I mean, okay. If you have you read my blog posts?
Sort of, some of them, yeah. And
yeah, so like if you're reading my agreement series, like the first half is going to be the post 1, but the second half is going to be post 3, which is not up yet. So like fresh content. So you can wake up at 5, so then you catch the second half of the talk.
Thank you very much. That's very